Welcome to this first video review for the year. And when we look at this, because this is the first review, we'll talk about a few things. For example, let me grab a pen here. Let's go with blue. I like blue. Okay. So the first thing, PS2, this means Physical Science 2. Learning Set 1. Each book this year will be divided up into several learning sets. The first few books have 3 learning sets, the last few books have 2. So basically we take a book which is a unit, so we only cover 4 units this year, but instead of having just 4 very large tests, we break it into learning sets. So we break it into smaller, more manageable pieces. This is the driving question that we have right now. Let me change pens. So this is the driving question for the book that we have, and I'm actually going to divide the review into 2 parts. That way it might be a 10-minute video for each one versus a 20-minute video altogether. Now when we look at the review, if you recognize this, it's basically the same as your paper copy. We're just going to go through in the video and we're going to talk, or I'm going to talk about each one a little bit more in detail, where on your paper copy you can be taking notes and you can use those to study for the test. So when we look at these questions aren't going to be on the test. This is not going to be an exact copy of the test. So for example, when I read number 1, be able to identify the relationship between mass, speed, and kinetic energy. And there's 2 bullets here. How does the amount of mass affect the amount of kinetic energy if speed stays the same? And how does the amount of speed affect the amount of kinetic energy if mass stays the same? So you're not going to see these exact questions on a test, but it's going to be very similar. For example, on the test, I might just simply have identify the relationship. So again, you see that word here. Identify the relationship between speed and kinetic energy. So this review goes into much more detail than the actual test. So if you can understand this, if you can answer these questions that you see in the paper copy and here, you'll easily be able to answer the questions on the test. So let's look at this. How does the amount of mass affects the amount of KE? Now here's the thing, if speed stays the same. So we know that KE, if we have mass, if the mass goes up, what's going to happen to the amount of kinetic energy if speed stays the same? If you said it will go up, you are correct. If mass goes down, so does the amount of kinetic energy. And think about this. Imagine that you're on the football team and say you're a professional football player. What would you rather get hit by, or who would you rather get hit by? A 300-pound lineman or a 200-pound punter if both are moving at the same speed? If you said a 200-pound punter, well, that's who I'd rather get hit by. Why? Because the mass is smaller, so the kinetic energy is going to be smaller. So what about the opposite? What about speed? What happens? How does the amount of speed affect the amount of kinetic energy if now mass stays the same? So again, when I look at KE and I look at speed, now we're taking mass out of it because mass stays the same. So what would you rather get hit by? A 300-pound lineman who's going as fast as he can go and say 5 miles an hour? Or would you rather get hit by that same lineman, that 300-pound lineman, if he's just walking maybe 1 mile an hour? So if you said you'd rather get hit by the 300-pound lineman going just walking at maybe 1 mile an hour, you're correct. Because as the speed goes up, so does the amount of kinetic energy. As the speed goes down, so does the amount of kinetic energy. But mass has to stay the same. If mass changes, it really depends. Say, for example, would you rather get hit by a 300-pound lineman going 10 miles an hour, or a bullet that may only weigh a few ounces but it's going hundreds of miles an hour? And you probably said, well, I'd rather go with the large lineman because I'm not going to probably die if I get hit by him. Well, hopefully not. But in that scenario, you're changing the mass and you're changing both mass and speed. On the test, we're not going to ask you that because that's a whole nother scenario. That's a whole nother situation. So on a test, we're going to assume both of these stay the same. And for example, on a test, if I ask you that question, identify the relationship between mass, speed, and kinetic energy, you would probably answer it. Kinetic energy goes up if the mass goes up, but what happens to the speed? Speed must stay the same. So you'd have to answer that on a test. You can't just say, oh, if the mass goes up, the kinetic energy goes up. Well, not necessarily if the speed stays the same, and vice versa here. So make sure on the test you say things like that, like, okay, the kinetic energy will go up if the mass goes up, if the speed stays the same. If the speed goes up, the kinetic energy goes up if the mass stays the same. On the test, I'm going to give you a scenario, and it will be similar to this. It won't be this exact diagram, but it'll be similar to this. So know at which point on the roller coaster, so A, B, C, D, E, or F, sorry about the E there, I cut off the bottom, but name which one of these will have the greatest amount of kinetic energy. So again, we're going to have to understand kinetic energy and what happens with kinetic energy. Well, as the roller coaster goes up, what's going to be happening to the amount of kinetic energy? You're probably going to say, is it going up or down? What are you going to say? Should be saying it's going to go down, because as you go up, the amount of speed decreases. And then at the very top, for a split second, it may stop as it starts to go down. Now, as it goes down, what's it doing? It's picking up speed. You have more speed, you have more kinetic energy. So at point D, this is where you're going to have the greatest amount of kinetic energy. And as it goes up, it's going to start to drop again. And there's nothing on this side. So if I was answering this question, I would say D. Now, be able to explain why. This is where it would have the greatest amount of speed. Now, some people will sometimes say C, well, but it's still picking up speed as it's moving towards D. So D is where it's going to have the greatest amount of speed. It's where it's going to have the greatest amount of kinetic energy. How about a different scenario with this same diagram? Know at which point A, B, C, D, E, or F on the roller coaster. Know at which point on the roller coaster will the car, grammatically doesn't make that much sense, but so where in this roller coaster will the car have the greatest amount of gravitational energy, GE, or potential gravitational energy, and be able to explain why. So again, if we have, this is the ground right here, and if I was to draw a straight line that's not very straight right there, that would be where you'd have 0. Now this might be like at Mount Olympus where the roller coaster goes underground for a little bit. But if this is where the ground is, how much gravitational energy would it have right there? And your answer should be none. It's on the ground. So the higher up you go, the more GE you have. So your obvious answer should be B. B is where it's going to have the greatest amount of gravitational energy. If I ask you where is it going to have the least, you should say D, because that's where it's closest to the ground. Here's a same diagram. Know what energy type is or are present at any of the roller coasters. So it basically goes back to the last two diagrams. Just know as you go up, your KE is going to be increasing. I'm sorry, your GE will be increasing, your KE is decreasing. But as you go down, your KE is increasing, and as your KE increases, your GE decreases. So be able to explain that, whether it's in this type of diagram, whether it's in a different version or a different diagram, just know what happens to KE and know what happens to GE. So when I look at the next slide, this is a similar question. Let's say I throw a soccer ball. It bounces here, and now it's moving upwards. What is happening to the amount of GE in a soccer ball at point A? Well, at point A, the amount of GE is going to be doing what? Is it going to be going up or is it going to be going down? Well, it should be going up. So as it's moving towards B, it's going to be going up. And it will continue to go up, 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 up until you get this point right here. And then as it starts to fall, the amount of GE is going to be decreasing. So what happens if we talk about kinetic energy? Again, as the amount of kinetic energy, as the ball is going up towards B, what's happening to the amount of kinetic energy? Is it going up or is it going down? It's the opposite of GE, right? It should be going down because as the ball bounces, as it's going down, it's slowing down, slowing, 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 slowing. And for a split second at B, it actually stops. And then it starts to pick up speed again as it drops, and then the KE would be increasing. So if you notice, there's a relationship here. Typically, as GE goes up, kinetic energy goes down. So that does conclude part 1 of the video, or the video review. So this covers, well, questions 1 through 6 on the review. So if you need to study those, or you take the test and you have to retake it, and you just need to really step up and study questions 1 through 6, make sure you look over part 1 of the test. Thanks.